Hi, everyone. Thank you for joining today's webinar. We're going to give it a minute or so for everyone to join, and then we'll be kicking things off. So I'm just going to wait a minute for everyone to join, and we'll kick things off. Excellent. So thank you for joining us today, everyone. We're really excited to be kind of taking you through a bit of a journey. And I'm really glad to be joined with two of really inspirational people in this sort of modern application development. They've been real thought leaders in this space. And today we'd really like to take the opportunity to unpack some of these sort of case studies and essentially the challenges we've seen in this whole transition in modern application development. So from my side, I'm Trevor Hansen. I'm a partner solution architect with Amazon Web Services. I've been with AWS going close to 4 years now, going from enterprise companies that are going through the digital transformation and now really working closely with startups that are helping enable sort of digital transformation and moving towards things like serverless architecture and so on. I'm also joined with Forrest Brazeal, who's a senior cloud architect at Trek 10. He's a really big activist in the whole serverless space, and I highly encourage going to look at his content. And I'm really glad to have him with us today and for him to give us some insight into his world and what they've been doing. I'm also joined with Nitzan Shapira, who's the CEO of Epsagon, a really cool company that I've been working with. I've had the pleasure to see them do amazing work for their customers, and I'm really glad to have him with us today to kind of show us what tooling and monitoring and landscape things they have in place today. So stick around. We have some really interesting content to cover today. So what is modern application development? And we're really going to focus on, with a bit of emphasis on serverless. From my side, I'm just kind of give you a bit of a, sort of the fundamental building blocks of these things. So let's take a look at what that is. So in this transition of, cloud has really disrupted things. We're looking at how, we're able to iterate a lot quicker, but it's also becomes, it's really, there's a lot of different moving parts. There's a lot of different services, and it's really difficult to kind of navigate through this area. But essentially, the high-level goal there is you really want to start leveraging these sort of modern services and applications that allow you to be able to no longer have to do the heavy lifting and undifferentiate the heavy lifting, where you can focus on sort of that core business value. So things such as containerization and serverless application development really allow you to sort of focus on really speeding up that flywheel, and we'll speak about that shortly. So you're looking at leveraging, services that are generated specifically for these use cases, so that you can just focus on leveraging those services and functionality rather than having to go and stand up servers and then patching and do all the other unnecessary things, which essentially just takes a lot of time from your teams away when they could really be focusing on those applications. So, seeing companies that are going through this transformation and starting to take really old workloads that, traditionally would have to go through this journey of, standing up servers and that would be handed over. I'm getting a bit of replay there.
Somebody just joined who should be muted, and they're gone.
Great. So let's take a look at what that enables. So once you've really, you started leveraging these serverless applications or services that allow you to start developing your application on top of this. So you're really moving towards things like APIs, and you're looking at sort of workflows and those things that we're going to unpack shortly. But you're really looking at something where you're running either sort of a container where you don't have to manage the cluster, or running something like a function, which is a Lambda function, which allows you to be able to not have to deal with the underlying architecture, but just have a piece of code that you can invoke based on, your what you want to essentially have as a source, and essentially have your code be able to run and be able to scale that really quickly. So what happens here? You really start looking at, this development lifecycle that we'll be unpacking shortly, but you really want to be able to start experimenting a lot quicker. And this is something that modern application development really enables. You're looking at serverless that allows you to be able to stand up a POC within minutes. In the past, you'd have to go through these long processes to essentially lock in resources and, still have to stand up servers. Now with modern application development, if your team has an idea and you guys, naturally would have some, flexibility to potentially play around, we all strapped with time, and it's really hard to kind of take your thoughts and put it out there in a little working example. This is something that serverless enables you to do really quickly. And that allows you to iterate and continuously innovate on behalf of your customers. They're asking for functionality and features. This really enables you to move quickly in those areas. So, going through that transformation, and I've worked with quite a few companies going through this journey, and, TrackSend does an amazing job working with their customers as well, is really moving away from these, old school monolithic applications where, as I mentioned, you have really, these large moving applications that have snowballed over a period of time, and, they're very sensitive. One area goes wrong, it could bring down the whole application, where, this is something that you should definitely look in a digital transformation talk, but moving towards those microservices architecture, really like decoupling things, allowing you to be able to group things together and allow teams to focus on developing and iterating on those particular areas. And this is what, allowing you to be able to do this, doing things like containerization and also using serverless functions and workflows, etc. So just to summarize on serverless, we really focus on this from AWS side, is when we're driving serverless services available for our customers, we really want to make sure that there's no provisioning or management for you to manage on a on a server level. You really want to be able to just leverage the features and functionality that that service provides. So if you're looking at from, functions such as Lambda functions, where you're able to run that piece of code for a short duration of time, or you're looking at sort of databases such as DynamoDB, you're not actually having to manage those servers that support that service for you. Another thing we look at is ensuring that that service can scale based on usage. And that's something that, companies that, from all sizes, from startup through to enterprise, moving to this sort of serverless architecture, you really want to be able to scale up to, the hundreds, the thousands, the millions, and the application and the server should be able to scale correctly based on, following best practices in serverless. Another really core, amazing thing that serverless enables is it's really cheap to be able to run these workloads, because you're not actually paying for, services or clusters having to sit there, and you're really trying to, squeeze every second out of that cluster. You're really focusing on just invocation sort of things. This is what Lambda is really enabled, where you're only paying for those couple of, milliseconds or, seconds that you're running that application. And another thing is, ensuring that this application can deal with failures. It's got fault tolerance built in by default. If there's going to be any problems with any particular areas, there's always things that are always going wrong. Vanna Vogel's had a really good talk a couple of years back saying that, continuously designed for failure. And this is something that our serverless service teams are really focusing on, is making sure that, once the service is available to you as a customer, that you have, this availability and fault tolerance built in, so that you can once again just leverage that application. So I'm going to quickly just look over this at a very high level. When we look at sort of serverless development, these life cycles, we're really framing it in a very similar way of what you traditionally do for development. You have that first phase of, discovering and prototyping and being able to put a concept, create a POC. Once you've established sort of that use case, there's amazing tooling such as, Epsagon, and so on, that allows you to be able to go through that monitoring component there as well. But you really want to have sort of a traditional sort of development experience, being able to have things that are plugged into your IDE, being able to do local testing and debugging. And this is something, for example, like our SAM, serverless application model, which we'll unpack shortly, is really useful. Once again, you can tie this straight back into deployments, where you're able to do your continuous integration deployments and be able to do your catches and your tests and those things. And then finally, once you got that out in production on AWS and you have this application out there, you really want to be able to have that visibility and monitoring in place. And this is, once again, a company like Epsagon provides that visibility, for end-to-end application monitoring, but also being able to pinpoint problems and be able to dive deep, especially because there's a lot of different moving parts. So that's kind of at a very high level. And then I just want to kind of leave you guys with 3 thoughts here on best practices, especially if you're starting this journey yourself at the moment. Treat your infrastructure as code. One thing you want to be able to do is templatize that application, really be able to, take a piece of sort of, code that is defined your architecture, where it be using something like CloudFormation or Terraform or Pulumi or Stackery, or, our serverless application model. Essentially, you want to have something that's it's repeatable, it's got version control functionality, and you can tie this into your workflow. But it also allows you to be able to move fast because you don't have to go stand things up manually anymore. You can apply this and it will go and create those resources for you. The next is obviously, what we've been doing in this journey in digital transformation is really setting up that automated deployments. And this is something that, something like Code Deploy or setting up some pipelines to automatically test and deploy your applications into production, where it be Canary or whatever the, your decision is as a company, but essentially making sure that you can allow your developers to focus on the development and iteration, and them allowing that process to release it out to production safely. And then the last is, and I cannot stress this enough, is having monitoring and observability from day one, understanding, in which direction your application is going and that you're continuously trending in a positive direction, but also having, the ability to quickly understand if something is going wrong and be able to figure out where it's going wrong. So that's it from my side. I'm going to be handing over to Forrest. He's going to be unpacking it from his side. And I really hope this has been useful for you. And if you have any questions, please reach out. I'm more than happy to dive deeper with you. Thanks a lot.
Thanks very much, Trevor. And I'm going to go ahead and try to take over the screen share if that's okay. You might have to let go of it. All right. Well, as Trevor said, my name is Forrest Brazeal. I'm a senior cloud architect at Trek 10. Hopefully you can see my screen okay. And so what Trevor did there, which is great, was to give us kind of the 10,000-foot overview of what modern application development looks like. What I'm going to try to do here over the next few minutes is to give you a sense of some really practical takeaways that we use here at Trek 10 in terms of what modern application development looks like for our clients, and how we're helping them to create business value for their customers. So modern application development tips. I'll be kind of using modern application development and serverless interchangeably, but of course, really what we're talking about here is applications that are built service first, that remove undifferentiated heavy lifting. And one of the big things that we can try to do there is to test code locally and test services in the cloud. I think this comes across as counterintuitive to a lot of devs because this is not the way we're used to working, right? We're used to writing our code on our developer laptops. We're used to mocking out any external services that we need to call. And that can work up to a certain point. But the reality is, as you're building these modern applications, more and more the things you rely on are going to be things you can't test locally. I'm talking about things like permissions issues, potentially configuration issues with these cloud services that you're building on. At some point, you just have to get into the cloud and you have to test there. So what I often recommend that people do, and what I've seen work well, is early on in your development cycle to go ahead and try to deploy some infrastructure into the cloud via a CICD pipeline. And we'll talk a little more in a minute about what that pipeline might look like. But I'm talking about things here like your IAM roles, perhaps a database, a DynamoDB table that you're using, just those fundamental pieces that sort of underlie your code. Go ahead and get those deployed into the cloud as soon as you can. And then at that point, iterate on your code locally using something like the AWS Serverless Application Model, or SAM, which Trevor referenced a minute ago. That tool actually has a local emulator that will let you run Lambda code in effectively a Docker container on your local machine. And that's great. You can write your code quickly that way. You can iterate quickly. But when your code needs to call out to a service, instead of sort of creating this fictitious environment for yourself with a mock, you're actually calling the cloud service directly. And that can help to smooth over potential problems that you might not catch until later on in the process if you were just trying to test everything on your local machine. Secondly, I do recommend that wherever you can, you optimize for less code. Not saying that code isn't good. Code is great as long as it is actually solving a business problem for you, but you don't want to get into a situation where you're just writing boilerplate. That's not the modern application development way. We'd like to have AWS take care of that for us. So wherever you can, try to use native integrations. I'm talking things like API Gateway now has, in addition to being able to call Lambda functions, of course, you can actually make calls against services like DynamoDB table. You can proxy directly to those services. So native integrations that I'm talking about, like API Gateway, now allows you to provide direct proxy integrations to a backend service. So you don't necessarily need that boilerplate code there in the middle. AppSync does this very well as well. It can let you talk to, for example, an Elasticsearch cluster. Your GraphQL schema translates directly to that integration. There's just no need to have a lot of extra code in there that you're writing. But with that said, and this kind of plays off both of these points, one of the things I try to have people do wherever they can is to prioritize writing end-to-end tests. And what I mean by that is actually testing your application the way your users are going to be using it. So you're going to be testing in the cloud very early on. And what that means is you'll have potentially testing frameworks that are calling your API. They're treating your application like the way your users treat it. And, you know, with these service integrations that we're writing, a lot of times we can't use traditional unit testing anymore. There's no framework that would support that. We've got to test a little bit more holistically. So what does that actually look like? I think to talk about that, we need to talk about CI/CD, and that's where I'm going to go towards. So some design best practices that I've seen work for CI/CD in a variety of different organizations. I'm going to go over a few best practices here, and then we're going to sort of look at an architecture design. I do see a lot of people going now for an AWS account per environment per app. We're moving away from the days where you had one giant AWS environment where you were placing all of your applications or even perhaps all of your environments, dev, QA, and prod. It makes a lot more sense to segregate those out. AWS accounts are the only true security boundary in AWS. If you want to limit the blast radius if you potentially have some sort of a breach, and then also really just the blast radius of errors. I really want to limit the possibility that I could deploy something to prod that I meant to deploy in dev. I want to protect myself against consumption of my service limits. So, for example, if I have one application that's chewing up all my concurrent Lambda invocations, I don't want them to be affecting other running apps. I'd like them to only be able to affect themselves. These are just kind of safety things that we see more and more people taking advantage of, particularly with the rise of management tools like AWS organizations. It just gets easier to manage and vend out these accounts for people. With that said then as well, we want to try to make our CI/CD pipeline infrastructure dynamic wherever we can. Gone are the days when we would have this one large build server and we would sort of treat it like a pet and we would tweak it manually if need be. The reality is we have more developers testing earlier and more often in the cloud. They're going to need to be able to spin up these cloud environments easily for testing. And that means that I also want them to be able to collaborate without stepping on each other. So envision I've got several developers that are working on different features on this same application. I want them to be able to test in the cloud without worrying that one of the others is going to affect something that they're working on. Dynamic pipelines are a really important feature. So in addition to the serverless app then being serverless, we want the pipeline itself to be serverless. We don't want to be babysitting a build server. It's really important that we find a way to kick out these pipelines without having to, for example, worry that one rogue job is going to take down all the disk space on our server. We'd like AWS to manage that for us. Just vend us out a build job whenever we need it. These are some best practices for CI/CD design. When we look at then what a CI/CD pipeline might look like for your organization, I'm showing you an account here. This is I'm calling it a shared services account. It's one of those multiple accounts that I mentioned wanting to vend out for your application. But in this case, it's not so much a development environment or a production environment as it is an environment that's sort of meta to that. It affects both of those. And so the things we might put here are going to be things like our code repository. In this case, I'm showing you AWS Code Commit, which is the hosted Git repository that AWS provides. We've got our code pipeline here. This is an orchestration service that allows you to take care of your development, your deployment steps, your build steps, sort of orchestrates those all in one place. We would manage our artifacts here as well, potentially things like parameter store, secrets manager. And so the idea is then that when we push code to this Git repository, we would also like to be able to have that pushed out to other environments where that code needs to be deployed. And the way we'll do this is with a dynamic feature branch pipeline. I'm talking about kind of a feature-based Git workflow here. I understand there's other workflows you might want to use. This is what I'm envisioning. So let's imagine we have a developer that pushes code then to a feature branch. What's going to happen here? You'll see we're going to trigger an SNS topic off of that push, which will then spin up a Lambda function. And that Lambda function, in turn, by this Rube Goldberg-esque process, will launch a dynamic code pipeline for us. And what that code pipeline will do is it will, in real time for us, go ahead and run any unit tests, linting, security scans, things we want to do on our static code, and then it will reach out via a cross-account IAM trust to deploy that code in our development AWS environment. So this is the second AWS account we've brought into play here. And the value, again, of this is this feature branch is dynamic. It's probably pretty short-lived. This pipeline only lives over the duration of the feature, but it allows our developers to really, really quickly start getting their code up and testing in the cloud so that they can quickly, as I said, get rid of that fictitious idea of trying to test these cloud services locally. So then what happens? We've pushed our code to the cloud. Ideally, we've tested it. We've seen that it works. We'd now like to merge it to master. Once that happens, we're going to launch a master code pipeline. This can be launched dynamically in the exact same way that I just showed you the dynamic feature branch being deployed, but with the caveat that the master code branch probably lives over the duration of our project, over the life of our application. So it's a little bit longer lived. And I've expanded this out a little more to show you what some of the steps in here might be. This obviously may vary depending on what your specific needs are, but you'll see a few things here. On the left, we've got AWS code build, where again, we're running probably our unit tests, our static tests on the code that gets pushed. We've got a deploy stage where we deploy via CloudFormation to perhaps a stable dev environment, a QA environment, whatever kind of non-prod place you've decided you want to stage your code before it goes to production. We can integrate Lambda functions directly with a code pipeline, so you could invoke sort of smoke tests, black box, end-to-end tests there if you wanted to. And then we'll want to create a change set, CloudFormation change set for our code. You'll notice I've got a couple of manual approvals involved here as well. It depends on what your organization needs here. Some people have kind of ITIL type requirements around change approvals, change boards. So it is really helpful that Code Pipeline lets you go in and you can manually give a thumbs up or a thumbs down depending on how that change set looks. Remember, CloudFormation lets you go in and look at what are the resources that are being managed in this infrastructure, what potentially will be changing here. So if you give approval, you then will hopefully execute that CloudFormation change set, by which I mean deploying your code to production. So we've now brought a third AWS environment into play here, and that's all being orchestrated via this same pipeline. Not the only way to do this. This is one potential way that I've seen be successful for various clients of ours here at Trek 10. If this looks a little bit overwhelming to you, the good news is you don't have to come up with any of the automation to build out this pipeline on your own. We've actually released this as a quick start with AWS. This has been out for just a couple of months. So we'll make sure we share the link to that here in the chat on the webinar. But you can go ahead and look at this today. You can look at the GitHub repository. You can go through the deployment guide, and that'll walk you through everything you need to get the design I just showed you deployed in your environment. And of course, if you need to go beyond that, which a lot of people do in terms of integrating it with existing systems, things like that, Trek 10 is more than happy to help you. Please reach out to us. That is what we do all day long. So we've talked about some tips for kind of testing in the software development lifecycle for modern apps and what that looks like in the context of CI/CD. Real quick, I just want to cover a few challenges that may arise here as you get farther into your development journey, because the reality is, modern application development does not come without its share of challenges. They're just potentially different challenges than you may be used to working with. So function sprawl is something a lot of people see. Lambda functions are easy to create. They are free if you're not running them. But for that very reason, they can be hard to keep track of. You'll wind up seeing that functions can live out there for a long time, so long that they have dependency rot. They have dependencies baked in with them that may have a vulnerability. How do you identify what those are? You'll see logic more and more moving to service boundaries. This is kind of a slippery concept, but remember, we're writing less code. So we might have, for example, instead of a loop inside of our function code, we might have that loop externalized to something like AWS step functions, where you have sort of a workflow that's defined in config that's looping around between functions. How do you test something like that? There's not a great test framework for just testing that logic. As these services become more event-driven, as they become more loosely coupled, we introduce a range of what I would call traditional distributed systems challenges. These are things like eventual consistency. I've got a whole bunch of different services possibly that are communicating over something like an event bus instead of them all being packaged together inside of the same process. How do I make sure they're all seeing the same view of the world, or that if they're not seeing the same view of the world, they're aware of that and they're making the appropriate decisions? As I have more asynchronous type of workflows that I'm running, these fire and forget type of workflows, how do I deal with failures that may arise? How do I make sure they get appropriately queued? How do I make sure I redrive or retry? Ordering challenges definitely are going to arise. Services like SQS, the simple queue service, are great, or SNS, the simple notification service, but they don't make guarantees about order, at least not unless you're using the FIFO queues. CloudWatch events, another great way to transfer events between applications, also doesn't make guarantees about order. Again, these are just things you have to be thinking about. They're not necessarily the way we're used to working. You have to challenge your assumptions there. And then inevitably, as you work with these modern apps, you're going to encounter apps that are less modern. There will be some non-serverless components here. For example, you might have to pull in a legacy database system, perhaps even something on-premise. This is just the reality of working in a larger organization. Things I have to deal with all the time. So when you integrate that, of course, you're going to cause problems where these two types of ways of working clash with each other. For example, a Lambda application tier where you might have thousands of functions scaling out, that can trivially knock down a traditional database. Traditional databases aren't designed to have that many connections hitting them all at once. So you have to think about how you're going to work with that. Ultimately, when I bring all these things up, what I'm trying to get to is to say this leads to systems that are complex and they can be hard to reason about if you're not familiar with working with them. So that's why Trevor is saying monitoring and observability are key from day one. And Nitzan, I think at this point, it's probably best to turn it over to you because you've got some solutions there.
So thank you, Trevor and Forrest, for the information and introduction and details about modern app development. It's really interesting to see, first of all, what AWS provides and the pace of innovation that allows customers to build software just faster and faster. And then how you can actually make use of all those services and technologies, as Forrest, as you demonstrated, what you can actually do to do things more efficiently with best practices, and eventually to move the business forward faster, to go to market faster using all those great technologies from AWS. So I'm going to talk about observability, and what our company does, Epsagon, is observability, monitoring, troubleshooting for these kind of applications that make use of all those services mentioned before. So before we go into, okay, what are we supposed to do about that? Let's talk about why is there a problem at all, or why is there a challenge? So first of all, when we talk about modern applications, we can see that it's not the same as the traditional types of applications. So like in the past, you had one server, you put your monolithic applications on those servers, and that's about it. You had your logs, you had maybe some basic metrics, and it would be pretty easy to understand what's going on. But now suddenly you have much more than that, because if you look at modern applications, you have services like Lambda, you have containers, and they are all communicating in very various ways of communication. So it's not direct service-to-service HTTP calls anymore. You have message queues, you have asynchronous events, you have triggers that are embedded in the cloud provider's domain, like the SNS example on the right, and many, many APIs that are being used for many types of purposes. So the complexity is just much higher, and some people even call it nanoservices and not just microservices. So it's highly distributed. We see customers that have 5,000, 10,000 microservices, and they are deploying dozens of new services every week. So it's very difficult to understand what's going on, to solve problems in production, to troubleshoot issues, and even just to build new features is a challenge. And on top of that, you have technological challenges that sometimes the host is not accessible. So how are you supposed to understand what's going on without access to the host? You cannot install an agent, you have no persistent storage, and so on. So the challenges are many, and most of them are just simply because the applications are becoming more and more complex. And if you look at the landscape and what people are doing today to understand what's going on in their applications, so usually it's going to be some kind of a logs agent-based solution. So they're going to take the logs, for example, logs AWS Lambda, they're going to ship it into some log aggregation tool, and then they're going to do some searching, querying, alerting based on these logs. And then on the other hand, you have metrics that are usually going to be infrastructure metrics, such as if you think about an EC2, you can look at the CPU usage. And generally, tracing and distributed tracing is something that is still pretty new and has not come to most of the organizations. And traditional monitoring solutions are usually based on agents. So you have to connect to the host, you need to install the agent on the host, and that's going to be just simply not possible if you use something like Lambda. And on top of that, if you want to get really good tracing that goes across all those types of events, it's usually going to be a lot of manual work and implementation to get started, because this is what is available today. If you look at all the frameworks like open tracing and so on, you're going to have to spend a lot of time learning it, implementing it, and maintaining it, which is going to eventually affect your developer velocity, which is the entire point, the main reason that you went into the cloud and into a modern application to begin with. So how can you actually keep up the developer velocity, enjoy all the benefits of the cloud, while having a very good understanding of what's going on, giving your customers the best experience, solving every problem quickly without spending much time coding observability? So that's what Epsagon is here to do. So it's an automated distributed tracing solution that is built specifically for modern cloud applications. So since it's agentless, it can run anywhere. So from Lambda to a container to something like AWS Fargate. And it's based on distributed tracing. So logs and metrics are great, but they are not going to tell the story of a complex distributed system. So that's why distributed tracing is key to understand this kind of application. Now I'm going to go a little bit more into the Epsagon solution and how it works, and then show a demo. So Epsagon, first of all, again, it's an agentless solution, so it can run anywhere. It's only a code library that can be inserted into an existing application very easily. And being agentless is key because maybe today you have an application running on a server and you're thinking about migrating it into serverless, or maybe it's already in a container and you want to put it on Fargate. If you're using something that is agent-based, you will get a gap. Once you want to do this transition, you won't be able to have the same monitoring in place. So being agentless is very, very flexible in that manner that it can run anywhere. Now, in order to get started with Epsagon, we have a set of integrations, as you can see on the bottom right corner, with tools such as Stackery, Serverless.com, Pulumi, Terraform, that can add the code inside with very, very little effort. And in less than 5 minutes, you can be up and running. And then there is really zero maintenance because it's automated. So once the code is inside, Epsagon will figure out automatically what needs to be instrumented. And then what you get as a customer, as a user, is a fully distributed tracing solution that is, again, automated, and it combines both the traces and the logs in a single interface. So when you want to troubleshoot a problem, everything is right in front of you. So complex problems that can take hours or even days to troubleshoot using logs can take suddenly minutes or even seconds. And again, the ability to run across many types of workloads is exactly what makes sense today in the state of the cloud and the fact that people are migrating to the cloud all the time. So they want to be able to work in the same way, no matter if they are using Fargate or running their own Kubernetes. Now, the first thing is the troubleshooting. So being able to trace through all the architecture, connect all the events together, and provide the logs, the metrics, and the payloads in a single interface is a great value, because then you can simply click and find all the data that went through the system to solve problems very quickly. Querying is another important capability. So just like people are migrating or shipping their logs into a log aggregation service, and then they query because they want to find a specific thing that happened in the log and so on, Epsagon allows you to query not just the log, but the actual payload. So it can be an HTTP body field, it can be a JSON of the SNS message, and any kind of payload that has been going through your application and Epsagon index can be queried, and then you can find, for example, show me what happened for that customer ID, and I get the transaction right away. Monitoring, of course, being able to see all the problems that you have. So again, if you look at the AWS console, you're going to get monitoring of, for example, Lambda errors. Sometimes that can be very valuable to find problems. So Epsagon will take those issues and a lot of issues that we discover on our own, and we present it all in the issues manager. So you can click and discover all those issues right away, and also, of course, get alerted in various many types of platforms that you already use, such as Slack, PagerDuty, Opsgenie, and so on. And finally, visualizing everything is a way to give the DevOps and the engineering confidence of what's going on, because when you know what you have in production, it's very easy for you to design, build, and deploy new things, where if you have no idea what you currently have, it's going to be very difficult to build new things. We've seen about 90% reduction in troubleshooting time across our customers, while the setup time is around 5 minutes or less. And the monitoring allows the customers to eventually get a much, much more decreased error rate. So many problems are actually being found and fixed before they reach to the customer. So that's a huge benefit to the business application. We work very closely with AWS. So for example, this webinar is one example, but the competencies and the marketplace that we are working with is very helpful to our customers because, for example, some of them really like the fact that they can use Epsagon directly from the marketplace, because then they don't have to, to approve any new thing. It's like purchasing another AWS service, so the integration is very slick. And I wanted to show just a few quick examples of how it looks like on a real application, because the screenshots are nice, but eventually everyone would like to see an actual product. So for the demonstration, I'm going to go into our public demo environment, so you can actually do it on your own. It's available without any sign up or sign in. And once you do that, you're going to have access to Epsagon in a real application. So I'm just going to try and start with a simple example. So I want to open one service that I have here. So this is an application comprised of both containers and Lambda. So you can see a Lambda function here. You can see an API call to Stripe, S3 trigger, DynamoDB call. And here you have two services running on ECS. One of them is Fargate, one of them is not. And they are communicating via a Kafka message queue. So as you can see, everything is automatically discovered, and it's also dynamic. So when something new is deployed, the map is going to be updated as well. And here we can take a look at the Lambda-based application that, as you can see, has several Lambda functions, again, multiple APIs, and specifically these functions has some errors. So Epsagon will highlight those to be able to fix it as quickly as possible. And the issues manager that I showed before will show all those types of issues. And let's say I want to fix one of these issues, such as the zero division. So clicking on the issue I want to fix will take me to the searching view with that specific query already in place. So I'm searching for this error that happens pretty often in my application. I can even see that it happens quite a lot last week, for example. And then troubleshooting is where it's becoming really helpful. So I'm going to take a look at one of these issues. And the troubleshooting is very straightforward because you can see the map of what happened from end to end. So the HTTP request came into the API gateway through Lambda function to an SNS to another Lambda function that failed, but I can already see that the Auth0 API call also failed. I can click on the SNS and get the JSON, the specific message that went through. I can click on this Lambda function and get the log directly from CloudWatch. So everything is really easy to get to. And even the API gateway, you can see the body, you can see the header, everything is here, and it's also queryable. Another example will be to query for the Stripe API calls that I have in another one of my applications here. So again, I can see that it's pretty common. And once I go and take a look at these calls, for example, this one, I can again see a trace of everything that happened. Also, being able to see it on a timeline view shows me that in this example, Stripe actually takes about 1 second. So think about AWS Lambda. This is time that can lead, for example, to a timeout. This is time that you're paying for, while the DynamoDB call is very, very quick in this example, only 4 milliseconds. And finally, being able to monitor Lambda functions specifically is also a great benefit. So just by deploying a simple cloud formation, all the Lambda functions can be discovered, and then you can identify errors, timeouts, out of memory conditions. And for example, you can take a look at this function that failed, and besides the basic graphs and metrics that you would expect, you get a table of each one of the invocations. And then you can say, okay, I want to get the CloudWatch log, and you get it right away. Or I want to take a look at this specific transaction, and I want to troubleshoot what happened there. So you can also connect to demo.epsagon.com. It's very easy, and play around with it. I just wanted to share one customer story because I think it's a very interesting story of Dunelm. It's a public company in the UK that they are selling home furnishing. And what they did, so they are a big company. Of course, not all of their applications are modern. Some of it is legacy, some of it is in the cloud. So this is very common in enterprises. But what they did is they took the e-commerce business, which is a very significant part of their business today, and they wanted to write it in a modern way. So they went to AWS and they used serverless and containers to write an application that is really state of the art. And for that, they have been using Epsagon across 2 locations, about 100 engineers in DevOps. And they've been able to use it not only in production, but also in development. So they found that development is a challenge, actually, when the application is so distributed, so complex, when you have thousands of Lambda functions, it's just complicated to understand what's going on. So using it both in development and in production was one of the things that enables them to decrease their troubleshooting time by 95% and simply build software faster and also a better software. And now finally, if you want to get started with Epsagon, again, you can do it also in development. It doesn't have to be in production, but of course, most of our customers use it to monitor their production workloads. You can sign up to a free trial of 2 weeks. You get access to our professional tier, which is usually going to be pretty good for you to get started with. And you can also use the free tier, which is forever. You can also get a one-on-one demo if you're interested, so we can go deeper like the demo I just showed, but you can also ask us any question. And of course, feel free to reach back to us and to me specifically with questions about Epsagon. So I think I'm going to hand it over to Trevor now.
Great, thank you. There is a lot of information that we covered in a short period of time there. I really hope that you guys found this useful. We'll be diving into some of these questions shortly. And feel free to reach out to any of us. You know, we continuously working with customers going through this journey. You know, this is kind of just a touch of the surface of, you know, that journey into developing serverless applications and, you know, really starting to use these tools in day-to-day production use cases. We have to help. We want to make sure that you guys are successful. We've seen people go through this journey and the pain points that they face. And we understand that every customer and every application is going to be different. So we really hope this kind of gave you a bit of some of the fundamental building blocks. But please feel free to reach out further. There is a lot of content that we put out there around different sort of case studies and reference architectures. I highly encourage you to go and play around, maybe even start up that quick start that Forrest and their team has been putting together. It's something that really helps you know, as a company set up that landing zone for your continued integration. And then once again, you know, as I mentioned, monitoring is absolutely critical. Having visibility in anything is really going to help you, you know, steering the right direction. So let's jump over to the questions and let's see what we have.